Hello, let's get started with the next section. Classes form the building blocks of software development and are essential for building good code. In this section, we will be looking at classes and generics and why we need to use them. We shall begin with the first video, creating and implementing an abstract class. Many developers have heard about abstract classes, but their implementation is a mystery. How can you, as a developer, identify an abstract class and decide when to use one? The definition is quite a simple one, actually. Once you understand this fundamental definition of an abstract class, when and why to use one becomes obvious. Imagine for a moment that you are developing an application that manages the animals in a cat sanctuary. The cat sanctuary rehabilitates lions, tigers, jaguars, leopards, pumas, and even domestic cats. The common noun that describes all these animals is the word cat. You can therefore safely assume that the abstraction of all these animals is a cat, and thus this word identifies our abstract class. You would then create an abstract class called cat. However, you need to keep in mind that you will never ever create an instance of the abstract class cat. All the classes that inherit from the abstract class also share some functionality. This means that you will create a lion class and a tiger class that inherit from the abstract class cat. In other words, the inherited classes are a kind of cat. Both classes share functionality in the form of sleep, eat, hunt, and various other methods. In this way, we can ensure that the inherited classes all contain this common functionality. Here we first need to create a new project, create a new console application, and call it Classes and Generics. Add an abstract class called cat. To do this, add the abstract keyword to the class. We are now ready to describe the cat abstract class. Add 3 methods to the abstract class called eat, hunt, and sleep. You will notice that these methods don't contain a body, curly braces. This is because they have been defined as abstract. As with abstract classes, the abstract methods contained within the abstract class contain no implementation. These 3 methods basically describe the functionality that is common to all cats. We want you to define 2 types of cats. The first type of cat we want to define is a lion. For this, we create a lion class. At this point in time, the lion class is simply an ordinary class and does not contain any common functionality defined in the cat abstract class. To inherit from the cat abstract class, we need to add cat after the lion class name. The colon indicates that the lion class inherits from the cat abstract class. The lion class is therefore a derived class of the cat abstract class. If you hover over the red squiggly line underlining the lion class, Visual Studio will offer an explanation for the error via the light bulb feature. As you can see, Visual Studio is telling you that while you have defined the class to be inheriting from the abstract class, you have not implemented any of the abstract members of the cat class. To implement these members that Visual Studio is warning us about, place your mouse cursor on the lion class name and click on the Show Potential Fixes link in the light bulb pop-up. Visual Studio will give you a small heads up displaying the changes it will make to your code. You can preview these changes by clicking on the Preview Changes link, as well as fix all occurrences in the document, project, or solution by clicking on the appropriate link. Click on Apply. After Visual Studio has added the changes displayed in the Suggestions window, your lion class will be correct and will look like this. You will notice that Visual Studio automatically adds a not implemented exception. In each overridden method, throw new not implemented exception. Go ahead and add some implementation to the overridden methods of the lion class. Now we will add some namespace, like using staticsystem.console. Next, we will create another class called Tiger that also derives from the abstract class cat. Then follow the previous steps and create the Tiger class and inherit the cat abstract class. Add the same implementation for the tiger class for eat, hunt, and sleep actions. For our lion class, add an enumerator for color spectrum and a property called lion color. It is here that the implementations of the lion and tiger classes will differ. While they both must implement the common functionality specified in the abstract class, namely eat, hunt, and sleep, only the lion can have a color of either brown or white in its available range of colors. Next, add the lion constructor in our lion class. This will allow us to specify a color for the lions in the cat sanctuary. The constructor also takes as a parameter a variable of the color spectrum enumerator type. Slightly similar to this, but quite different in color, the tiger class can only have a color spectrum enumeration that defines tigers as being orange, white, gold, blue, or black. Add the color spectrum enumerator to the tiger class as well as a property called tiger color. Finally, we will create a tiger constructor for our tiger class to set the colors of tigers in the cat sanctuary to the valid colors that tigers are found in. By doing this, we are separating certain functionality specific only to tigers and lions in their respective classes, while all the common functionality is contained in the abstract class cat. We now need to instantiate the lion and tiger classes from the console application. You will see that we set the respective cat's color from the constructor. Here is the lion class and its objects. And there is the tiger class and its objects. Run the code. You can see the output here. That's it for this video.